and control of gas and diesel power plant. For this amazing session, we have our worthy guest speaker, Mr. Obayo Ajri Moses, will be joining us. He is energy infrastructure and gas and diesel generator engineer. He is also a plant engineer along with holding the title of Automatic Control Certified. So, make sure you don't miss out this amazing opportunity to learn from the best, which will not only enhance your knowledge but also help you in clarifying your pathway. Thank you, sir. You may continue.
Okay, thank you, Muhammad. Good day, everyone. Thank you. You're all welcome to the session of maintenance and control of diesel and gas power plants. First of all, I will just give you a simple analogy of how this control works. Control first, then secondly, I'll discuss about maintenance. But I will try as much as possible to make this first session, summarize the first session that will conclude in session two. Now, in the first session, we are going to discuss about the three major device in control, which is sensor, controller, and control device. Sensor, controller, and control device. Now, these sensors are being installed into the generator. The control device receives the information from the sensor and process it and send it to the temp evo. Then the temp process and send to the LMS. The LMS send it to the SCADA. The SCADA, you do your normal operation from your SCADA. Either you close your outgoing from your SCADA, you start your generator from your SCADA system, and all and all. So it's just a brevity, a simple analogy of the control system. Now, generally, control system is divided into because of the operation that we have in our industry today. Now we have the low voltage control system. Then we have the medium voltage control system. Now the low voltage control system control a mode of operation in the gas and diesel generator is kind of easy, but the medium voltage is very complex. But the difference between both of them is that the medium voltage is safe, but the low voltage control system is harmful, it's dangerous because of the control room, because of the resistance, because of the tension, because of the radiation inside the control room. First of all, we are going to discuss about the sensor. Now, what's a sensor? What do you understand by a sensor? A sensor send output signal, send a signal or an output signal, send it to any of from one controller to the other. While the controller job is to receive the signal from the sensor and process it, either display it on a system or store it or digitalize it. Then the control device are the one that does the function. They are the functional operational module for the sensor. When the sensor energizes, the control device work in line with the signal sent from the sensor. Now we have different kind of sensor incorporated into the generator. When the generator is running, there are the various sensors that have been installed there to perform different function. Now we have AKS. AKS means anti-knocking sensor. So this one is preventing knocking on the generator, either to prevent to give you signal when the oil level is going down, or give you signal when the LT, the low temperature or the high temperature volume is going down. So we also have the temperature sensor, we have the pressure sensor, we have the position sensor, we have the proximity sensor, proximity, PROXIMITY, proximity sensor. The proximity sensor does the closing and the opening of the stepper motor to allow gas to come into the gas mixer. That's the function of the proximity sensor. So once the gas pressure regulator is being adjusted to the set volume or set regulation from the operator, then the proximity sensor will sense it automatically and allow gas to flow into the gas mixer, mix it with the air and fuel. Then from there, you now see normal going to the combustion chambers. So that's just for the proximity sensor. So we have different kind of sensor incorporated into the generator. But what we are going to, that's not what we are going to. You all go and make research on what a sensor is. A sensor is just a device that sends a signal, an output signal to a particular location, either to a controller or sent to a control device and being processed and being resent back to the sensor to energize and start operation and receive signal again. So it's just a kind of like open and a closed loop operations from both ends. Now, going forward, from the sensor in a generator, there's a way this thing is being streamlined. And the way this streamlined in the sense that when the sensor sends a signal, they want to call ignition system. Ignition system is called a TEM EVO ignition system. The TEM is an acronym, TEM-EVO, TEM EVO ignition system. The TEM EVO ignition system receives all the interpretation from the sensor that's been installed into the generator. It receives everything from the sensor and send it to the AGS panel. The AGS panel. The AGS panel, inside the AGS panel, we have what they call ROTU. ROTU means remote telemetry unit. Remote telemetry unit. Although that's the old name for the ROTU, but the new name now they call it remote terminal unit. So what this ROTU does, it receives signal from the ignition TEM EVO ignition system and convert all the languages from the sensor into readable variables. And these readable variables is being transferred through an I/O controller. I/O controller, it means input and output system from the generator. Hello?
Yes, it's audible. Please continue.
Okay. So it sends the signal to the I/O controller. The I/O controller display will now send the information gotten from the ROTU, which is the remote telemetry unit, and will now display it in an HMI. That HMI is called TEM EVO. It's called TEM EVO. The TEM EVO is an engine generator electronic management system. It's a modular system, although it's not a PLC, but it's just a modular system to display the information from the PLC regulator, which is the ROTU. Now, there's also a PLC embedded into this, the AGS. AGS, if you may ask, what meaning of AGS? AGS means auxiliary genset system. Auxiliary genset system. That's where all the generator controls is being installed inside the generator shelter. The AGS is located in the generator shelter, while the TEM EVO is embedded inside the AS panel, which is located in the control room. So the TEM EVO is found inside the AS panel. So aside the signal being sent through the I/O controller to the TEM EVO, the I/O controller is also linked to a PLC called Profibus. And the Profibus is also located inside the TEM EVO. It's an internet. The Profibus is an internet that sends signal to the LMS. LMS means load management system. It's the brain of the generator. If the element is off, if you off the LMS, the generator will not start until you power the LMS on. So the LMS is the brain of the generator. So the I/O controller is linked to two terminals. It's linked to the TEM EVO HMI, human machine interface, and also linked to the PLC, which is the Profibus. The Profibus that send the signal, is an internet that collects all the process information from the ROTU and sent to the LMS. The LMS is load management system, and the LMS is also having its own panel inside the control room. All those things I'm saying now, some are inside the gen shelter, some are inside the control room, while some are inside the main office. These are the three compartments. On our last lecture, our previous lecture, we talked about the various compartments inside a power plant. In that gas or diesel power plant, they have three compartments. The first compartment is called the gen shelter. The second compartment is the control room. And the third compartment is the main office, where operators are sitting down, where operators do their documentation, where operators take their reading is in the main office. But on no condition must anybody enter into the control room and the gen shelter, because the gen shelter is very noisy. I'm just paraphrasing our last discussion. The gen shelter is very noisy. The sound rating for the gen shelter is above 100 decibel. So you need an ear plug and an ear muff to be able to access the gen shelter, because the noise coming from there is very loud. It's very loud, very, very loud. So it's expedient you wear an ear muff or an ear plug when entering the gen shelter. So now, inside these three compartments, we have an AGS as one of the control module housing for the control inside the gen shelter. Then we also have HAS panel, LMS panel, GLF panel, and your auxiliary panel and your MV panel incorporated inside the control room. Then we also have your SCADA system inside the main office. From the main office, you connect the VGA. You connect your VGA from your laptop or your desktop to your VGA on the LMS. So the essence of having an LMS in a power plant is for you to be able to access your information through your laptop. So by connecting your laptop to your LMS, you can access all the information. What you just do, just get a laptop, install a SCADA software, and when you install SCADA software, the LMS is already a program. So what you just do, just carry your VGA, a designated VGA from the manufacturer, connect it to your laptop, and you can access all the information of the generator from your system. You can operate it from your system if the SCADA system is well installed, because sometimes this SCADA system are not well installed. So the SCADA system, if it's well installed, you can operate your generator. You can close all your breakers, your ACB breakers, your air circuit breaker, because these modern generators now, they are using air circuit breakers. They're no longer using your MCCB, your modern case circuit breaker, because the system is revolutionizing in the sense that the air circuit breaker uses a logic. I'll come to that. I will come to that point later. The ACB uses a logic, while the MCCB just uses a mere block arrangement. It's a mere block arrangement. So that's why they don't use the MCCB. It's phasing off. The only generator that uses MCCB is your MTU. Your MTU uses MCCB. But apart from MTU, no other modern generator, MWM, Jembaka, Caterpillar, and the rest, none of them uses MCCB anymore, because it's outdated. The modern breaker that they are using now is ACB, air circuit breakers. That's it for that. Now, when your sensor sends the signal to your ignition system, this is the process flow. Your sensor sends signal to all the signals being processed by ignition system. And this information received by the ignition system, it cannot be read by you and I, because they are just mere logic. If you the type that study electrical, there's a topic in electrical called logic gate. So in that logic gate, there are some this generator we are talking about, there are 12-cylinder, 16-cylinder, and 20-cylinder generators. Now they are V engine, and under the V engine, in your right hand side we have a bank A, in your left hand side we have bank B. So bank A for a 12 cylinder is 6. Bank B is 6. 6 plus 6 give you 12. So under this 6, if you distribute it very well, you will align all your logic gates on it, which is your example of your logic gate. We have OR, we have AND, we have XOR, we have NAND, we have NOR, we have XNOR. So these are the logic gates. Now, this information that being processed, and they are processed using a binary number, binary 0 and 1. So 0 and 1, something you cannot understand. And these are the information that the sensor sends to the ignition system. The logic gates, they are being distributed in a format called a truth table. So this truth table, each and every one of these logic gates has its own arrangement. For an AND logic gate, we have 0, 1, we have 1, 0. That is a AND logic gate. So this logic gate now is a language that you cannot understand because they are all written in binaries. Now, for these binaries to be converted to something you can read, for example, let me say, for example, temperature sensor, and each of the combustion chambers has a temperature sensor incorporated inside each of the chambers. You know, we have a B engine configuration. We have 6 here, and under the 6 we have A, B, C, D, E, F. So just different numbers for 6 here, bank A and bank B. Now on this other side, we have C sensor that senses individual combustion chamber of the generator for bank A. Then from bank B, we also have a sensor like 6 also. I'm talking about the 12-cylinder engine that senses the sensor. Now, this sensor, when the sensor senses the temperature of that particular combustion chambers, it's not written in normal language that me and you understand, because the language me and you understand is Celsius or Kelvin. Celsius or Kelvin, although your ROTU will convert it to Celsius. Your ROTU will convert to Celsius. So when this sensor senses the temperature, they are written in binary numbers because they are all in logic gate form. So they are all written in binary numbers. So these binary numbers is being received by the ignition system. The ignition system, the essence of the ignition system is to receive all the interpretations, all the languages, all the output variables from these sensors. And it processes it, and through a signal cable, is being connected to the ROTU. The ROTU will now convert these binaries into readable variables that you and I can read. For example, you convert the temperature, the information received for the temperature sensor, you convert it to like something like, for example, if the combustion chamber is reading 350 degrees Celsius, which is the average for a normal working perfect combustion chamber, the sensor will read 01 or 0110 from its own interpretation through a logic gate. Then the ROTU will not convert it to like 350 degrees Celsius. They will not send it straight to your IO controller. And from your same EVO HMI, human machine interface, you can now see the various temperatures of each bank displaying. So that's the essence of that ROTU, to convert all these binaries into readable variables so that human can access it. That is why they call that area where you can access it called HMI, human machine interface. It's where an operator can access any information. And from that HMI, you can even use your flash drive to copy out the history of the generator performance. You can copy out the history of generator performance if you really want to check whether the generator is due for change. you can know from the temp level. You can know from your HMI. So that is the process flow between a sensor, temp level ignition system, RTU, the IO controller. Then the IO controller is linked to two points, which is the PLC, which is the Profi bus, and the temp level, which is your HMI, where you can access any information. Now, the Profi bus is linked to your LMS. That LMS is your load management system, where you can is the brain of the generator, where you can, if the LMS is off, your generator will be off because all the controls is being processed inside the LMS. So if your LMS is on, your generator can be powered, can be on, because depends on the automation engineers or the person that automated your power plant. If you automate your power plant in a way that you can individually control the operation generator, either from the temp level or from the LMS, fine. But some people prefer to link all the brain to the LMS. Reason being that because it will protect all your sensor from burns. You hardly see a sensor that is linked to your LMS get burnt. It's not possible. Either another component will get burnt and the sensor will be protected, because the sensors are very, very expensive, especially that for Jenbacher, that for MWM, and that for Caterpillar. They are very expensive because Caterpillar bought MWM in 1985. So Caterpillar is now the co-owner of MWM generator, and they've modified their engines. They've modified the engine of MWM now. So MWM now is now kind of like owned by Caterpillar. So the few percentage that some of the directors of MWM own inside Caterpillar is not up to like 20%. So that's for that. Now the SCADA system is linked from the LMS to your main office through your computer. So from your computer, you can access each and every information from your system. And all these things I've been saying now is just centered on low voltage control system. Low voltage. I've not talked about medium voltage. This for low voltage only. So this session, I'm going to discuss about low voltage controls module only. But in our next session too, we'll talk about medium voltage, because this control, this PLC's control system, they are it's a very, very broad topic. Now that's for control. So before I go further about the control, if any of you have any questions, let him ask, so I will not get ourselves lost, so not get ourselves confused. If you have any question, you can ask, please. I'm all ears.
I think so. Moses, just continue. If anyone have question, they can ask.
You guys should continue. Okay. Now we have what they call LT and HT, low temperature and high temperature. The LT and HT has individual diaphragm expansion valve. It's called diaphragm expansion system, rather. It's an expansion system that controls about pressure wave in the pipeline that links to the radiator. I come again. They want to call HT and LT. Now, LT is called the intercooler. HT is called the jacket water. So this HT and LT is what flows within the jacket. The LT flows within the jacket water to cool the various engine cylinders. The way the cooling operation works in a generator, first the oil cools the engine, then the HT cools the oils, because the oil you first on it when you on your auxiliaries, you run the HT, when you on HT, it will raise the temperature. Then before the HT comes into the generator, what we call preheater. A preheater is a box that have two major elements. The essence of those elements is to raise the temperature of the water that's coming into the generator to meet with the expectation of the generator. For example, when your temp able send a signal of a temperature going down from the generator through the sensor, every combustor chamber has a particular temperature range. If you go below that temperature range, if you don't work up to controls the way the temperature runs down, you may have a downtime or a shutdown for that generator. For example, each combustor chamber from bank A and bank B, the least amount of temperature that is allowed is 300 degrees Celsius. 300 degrees Celsius, 300 degrees Celsius. And all this function is being imputed by your HG and by your oil. By your HG and by your oil. Now, if this temperature goes below 300 degrees Celsius to, for example, 290 degrees Celsius, it should affect your generator will not be linear with the operation with the other banks, because both banks work in linear with each other. So if, for example, bank A1 is 300 degrees Celsius and bank B is 280 degrees Celsius, with time you have a shutdown. So you need to check several things, several control components there in order to harmonize this to correct these anomalies. If not, you have a downtime. And the only thing you can check there, one is your ignition coil, two, your ignition cable, and three, your spark plug. Now, that is it for the control. We are going to maintenance now. I'm just giving a brevity of those things so that because of time. Now, the maintenance is done on every generator based on running hour. I come again. Maintenance is done on the generator based on running hour. And the running hour depend on the manufacturers, in the sense that manufacturers give the various running hour for the maintenance of each of their generators. For example, MWM, they have a standard for their running hour. Caterpillar has their own standard. So Caterpillar cannot compromise the standard of MWM, despite the fact that they purchased the company. They have the largest shares in the company. Jenbacher cannot compromise the running hour of Caterpillar because they are individual companies. Jenbacher is owned by General Electric. That's it. Now, there's a code established for maintenance. We are in maintenance section now, maintenance section. There's a code established for maintenance of every gas generator. Diesel generator, this code is not applicable. But for a gas generator, this code is applicable. Why the code not applicable to diesel generator is this? A diesel generator is a one-way generator. The standard you apply when running a 250 kVA, you can also apply that maintenance strategy when running a 500 kVA. The maintenance strategy you apply when running a 500 kVA, you can apply the same strategy when running a 1100 kVA. Because generator rated in kVA, and kVA is your apparent power, because under the power triangle we have real power, apparent power, and reactive power. So every generator rated in kVA, the real power there for a 1100 kVA is 880 kilowatts. 880 kilowatts. The same application you apply for 250 kVA, you can apply it in a 1100 kVA. The same way you apply 1100 kVA, you can apply it 1500 kVA. So same like that in the streamline. But for a gas generator are very sensitive. They are very, very sensitive, and they are the parts are very, very expensive too. Like I said in the previous class, the parts are very, very expensive. That's why people doesn't employ operators with less experience to manage the plants. Slight mistake, generator component, one of the components may just go. And when it goes, replacement of that component will cost you a huge sum, and may even risk the employment or even tender a termination of employment of the operator that's involved in the downtime of that particular generator at that particular period of time. The code established for a gas generator goes like this. We have E10, that's for maintenance I'm talking about. The code established for maintaining a gas generator. We have E10, we have E20, we have E30, we have E40, we have E50, we have E60, and we have E70. All this code I just mentioned now, they have their various mode of operations, and they have their own various activities that you adopt when running this code. It's imperative you understand this code. If you don't understand this code and you go into a power plant as a maintenance engineer, because normally they want to employ you in a gas power plant, either they employ you in two roles. Either you are a operation and maintenance engineer, or you are a plant engineer. The under plant engineer, they may call you a shift engineer 1 or shift engineer 2. Then they may call you shift engineer 3. So if you don't have this knowledge of this code, you will just go and be bench warming in a power plant, and you will not have any clue of the operation. You just be following the trend. You will have a zero knowledge about these operations. When I was going for a training with MWM on this code, they asked me a question. If you commission a plant, which of the code would you implement? I don't know. Normally you have to check your generator every 1 hour during operation. If your generator is running, your power plant is running either gas or diesel, it's expedient that you go into the gen shelter with your earplug off every 1 hour to check the operation. Which of this code does this thing fall into? You don't know. You need to carry oil change on your generator every particular hour. Which of this code does it fall into? You don't know. At the particular point when your generator runs, you need to carry out overhauling. Which of this code you need to fall into? You don't know. Now, in this lecture, you are going to know the various code, the various activities, and the various operations you have to adopt to achieve all this. First, E10. E10 means it's a commissioning preventive maintenance that you carried out. Commissioning preventive maintenance. Now, how does it work? This E10, whenever you commission a power plant, for example, let me say, for example, you commission a power plant in Qatar, in a particular location, in an island mode, isolated place. Before you open, you start this power plant, you have to check each and everything you have installed before you run the plant. You have to check the oil level in the day tank. You have to check whether your used oil tank is well connected to the pump. You have to check if your solenoid valve that opens and closes when your oil level goes down, whether it's working. You have to check the solenoid valve, whether the magnet inside is clicking. Because you know when you connect the solenoid valve, if you put an iron inside or anything, it will be sucking it, to be dragging it through the magnetic force. You have to ensure that is magnetic, is working perfect. All this check you do inside the generator at the commissioning stage is called E10, to ensure that the plant is ready to run. It's ready to run. It's ready to perform. Ready for production. It's ready for use. So all this check you do, check your air level, check your water in your radiator, your HT, your LT, all these things you do is called E10. During E10, ensure you check your cabling, especially because when there's a leakage, you are likely to experience issues with your AVRO, because a gas generator AVRO is very, very sensitive. And that AVRO has what they call potentiometer. The potentiometer is just a language established by a physics person in electrical. But the real words, the other word called a variable resistors or a variable resistance. So inside the AVRO of each generator, there's a potentiometer. The potentiometer, you can adjust the frequency to any direction of your choice. Because inside the AVRO, we have frequency regulator there, we have a potentiometer regulator there, and we have a lot of regulation inside the AVRO. You can adjust your voltage there, but the voltage, that AVRO can get burnt. And when that AVRO gets burnt, your voltage will not be stable. And when your voltage is not stable, you'll be having fluctuation in voltage. And of course, you know, the voltage is the force that pushes your current through a circuit. So if your voltage is not balanced, your current will not be balanced. And if your current is not balanced, your customer will complain. The various factors, because when your current is not balanced, therefore, remember, your frequency will be fluctuating too. Normally, the frequency standard for every country have their own frequency standard. US frequency standard is 60 Hertz. Africa frequency standard is 50 Hertz. So other countries can use 60. Other countries can use 50. It just depends on what they want on their own operations. If your voltage is not balanced, know that your AVRO is a challenge. And when your AVRO is challenged, know that you didn't do a thorough E10 during commissioning. So it's expedient that you carry out serious check. And when you're carrying out a check on a power plant during commissioning, take your time. Don't be in haste, because this check can mine you or make you as a commissioning engineer. If you see some adverts that company advertise, they say they want a commissioning engineer. The commissioning engineer, your role is to ensure that a plant you must solve.
I don't understand anything, sir.
Any question, please? Everybody saying something?
Yes, Tayyib, ask question if you have.
Should I continue?
Yes, continue, please.
Okay. You see a role called commissioning engineer 1 for a company. There are so many companies recruiting for commissioning engineers. Commissioning engineers is a very strict role, because these days, graduates just rush to apply for job. Just see a role. Electrical engineers, you must have a BNG or a bachelor degree in electrical engineers. You must have experience, so you just quickly apply. It's a very dangerous role. If you are not careful, they will lay you off after 6 months. Commissioning engineers, your role is to perform E10 after plant has been installed, because first, the platform where you are going to mount your generator, you as a commissioning engineer, you must ensure that that platform is well designed to withstand vibration and shock. So it's not just a child's play. The platform must be well installed. So all those things, they are E10 you incorporate when carrying out your preventive maintenance to prevent future issues, hazard in the future. That's the whole essence why you establish preventive maintenance. You put this in place. In fact, in that E10, you carry out all the phases of engineering maintenance that you need to adopt, either corrective, either preventive, either predictive maintenance. Everything is well incorporated inside E10, because it's a serious issue if the plants are running and start having issues, especially when it's something of substandard is being installed in the control room. For example, we experienced a case in one power plant is an MV, medium voltage power plant, in the sense that when your generator is running, it will pass through a step-up transformer. Generator generates 415 volts. When it gets to a step-up transformer raises it up to 11,000 volts. Then when it raises it up to 11,000 volts, it sends it back to your GLF panel. So your GLF panel will synchronize on 11,000 volts before it will now send it down to your step-down transformer. Then when you get to the step-down transformer will now send it down to your individual isolators. The component installed on the control room was substandard. There was not they weren't this austerity check on these various components. The commissioning engineer did not do his check very well. He was sacked eventually. He was sacked. He was laid off because he was employed for that purpose. That project worth over 1 billion to establish that project. It's a very expensive project, very expensive. We have over 6 generators. And one of the generators is 2,500 kVA, which is 2,000 megawatts, which is 2 megawatts, sorry. So now, imagine such a mighty generator, and we have 3 gas, 2,500 kVA, and 3 diesel, which is 6 together. Now, these generators are meant to synchronize together to power the full company. But there was a mistake during the cabling from the transformer to the synchronization panel. Because first, there are 2 wires that run to the generator. One from the transformer to the from the generator to the transformer. One signal wire from the generator to the deep sea electronics. This electronics is like a control module for generator in your in-command. So this signal cable was not well connected to the bus bar, to the GLF panel, because that's where the bus bar is. The thing started getting burnt. The deep sea electronics started getting burnt, and one of that deep sea electronics is very expensive, over $1,000. One of it is over $1,000, and we have 3 for the 3 gas generator, and we have 3 for diesel generator, which is 6. We lost 3 of the deep sea electronics in 1 month. We lost 3 after the plant started running. Because why? There was no proper and thorough E10 that was carried out on that plant. So you have to sack that guy and employ a new commission engineers to come and re-evaluate and check what the problem really is before they now spot the issues and they now solve it. And the plant, up to today, the plant is still running seamlessly without any challenge. So what am I trying to say in essence for this long student? I'm just telling you. What I'm trying to say in essence is that you have to be very careful when carrying out all these preventive maintenance, all these maintenance activities in a gas generator or diesel generator, because if you don't take it very well, you will continue to be having issues, shutdown, downtime, shutdown. And when there's a shutdown, especially when you are working in a production company, a company that produces and they work based on targets, you are in big soup. Because if you as your gas and the power plant operator is not efficient enough to run the plant to maintain 0 downtime, because the whole essence of a power plant engineer, the whole essence why you are learning this course is to have the 0 downtime. And the things you put in place to have the 0 downtime is what we are talking about now. All the things you need to adopt, all the practices you need to put in your mind. You being a student or professionals, the thing you are missing out, because there are a lot of professionals that are working in the various companies. They are just bench warmers. They are not the type that learn. They don't read. They are just following trends. Just some of them they are only to take reading and go home. They are bench warmers. If you call them for an interview, they will flop, because why? They are wasting. I have a lot of friends that have spent like 4 or 5 years in the company. They know nothing about power plants. Because why? They are bench warmers. They are just there to earn salaries. They are not there to learn, to increase their knowledge. Because normally, if you go to a power plant, you have to ask for the manuals of the generators. Because we have 2 kinds of manual. We have the generator manual, the general generator manuals, and we have the operator manuals. The operator manuals will give you a guide on how to run the plant seamlessly. All the maintenance you need to carry it out are all embedded inside the operator manuals. That's it for the E10. Now for E20. E20 is a very easy preventive, it's a very easy maintenance. And E20 also encompasses all the three phases of maintenance. We have inside E20, embedded inside E20, we have corrective. Inside E20, we have preventive. Inside E20, we have predictive maintenance. So all this E20, the name for E20 is called routine check. Routine check. The name for E10 is called commissioning maintenance. Commissioning maintenance. Commissioning maintenance. And the commissioning maintenance can be either be predictive, corrective, or preventive. The same thing with the E20, which is the routine check. Preventive, corrective, predictive. You adopt all these maintenance inside them, because during power plants running, it's expedient. It's very, very important. It's very, very imperative. You carry out hourly check on the generator. The standard is 1 hour. Every 1 hour, it's expedient to enter into the generator, walk around the generator, work both in the generator, both in the auxiliaries, both in the control room. Check and be sensitive. Make sure your eyes can see. Make sure your ear can hear. Make sure your nose can smell, because sometimes something will be burning somewhere. You will not be aware of it if you cannot perceive very well. I know of a guy. I'll be standing here. I'll be hearing smell. I'll be asking, "Are you perceiving the smell?" He'll say, I'm not hearing the smell. I cannot perceive it." So make sure your sense organs are working perfectly when you are carrying out routine check. Because if you don't carry out routine check, you put yourself into big mess. For example, routine check is done every 1 hour. That is standard by policy, by national policy. Is standard. You run your routine check every 1 hour. Every 1 hour, it's expedient. You walk into your control room and your gen shelter every 1 hour, and also climb up to your table cooler, which is your radiator. Climb up, check whether there's water inside the radiator, because sometimes the water in the radiator may have gone down. You will not be aware of it. You just be carried away by said you are working, you are an engineer, and you just go take reading and go and sit down in the office, collecting your air condition, enjoying yourself. You will not know that your water in your table cooler, which is your radiator, has gone down. And if the water goes down, fine, the water has gone down. Water will not pass through your jacket water anymore. What effect is that? Overheating will start. The generator will overheat because, one, when the oils run around the engine to cool the engine to various cylinders, your water is meant to cool the oil and also cool the jacket. Imagine there's no water running through that line and your generator is running. You see temperature will skyrocket. Your jacket water temperature will rise from 50, because the standard for jacket water temperature is 50 degrees Celsius. Imagine you just see 86, 90. What? You'll be shocked. Imagine your plant maintenance manager or the plant manager in that location just, young man, have you gone to check? Say yes. Himself stood up and went go and check the power plant and look at the HMI and saw inside the various bank of the combustion chambers is seeing over 86 in the jacket water. What? That is crazy. You're going to have a serious shutdown, because one, the gasket is gone, it's burned complete. Your jacket is gone complete. It will get burnt immediately because the engine is very hot as in operation. Imagine each combustion chambers of the generator, they are having 350 degrees Celsius, 400 degrees Celsius, 450 degrees Celsius. Imagine the normal standard temperature that you know about, the boiling point is 100. Imagine you put your hands in boiling water. What does it do? It burns you. It will peel off your hand. Now think of something over 100 degrees Celsius, something like 300 degrees, 400 degrees, coming out for a power plant for a generator of like 2 megawatts, 2 mega like 200, 2,500. You didn't do thorough check, no routine check, just feel laxity. You're going to burn that shut down the full plant. So it's imperative you walk around the power plant, check your various components, check your diaphragm expansion tank, check, ensure that they are working, check the pressure gauge, ensure that they are working perfectly. Anyone that lacks oil, you lubricate. Check your generator gauge, ensure your pumps, everything is working seamlessly. Ensure your thermostats, everything is working. Ensure the crankcase breather is giving out a lot of breathing it out. Ensure everything is working. Just a check, it's a routine check. It's not a big deal. If your plant is okay, or for a new plant, it's very easy for a new plant because a new plant is well commissioned to run seamlessly, to be very okay. You don't have stress in the first 3 years if it's a good, well commissioned power plant, well commissioned one that a very good E10 was carried out on it. You don't have any issue. But if it's an issue plant that quirk, non-professional person was employed to go and commission that plant, you will have big problem. You, the operator, and a plant maintenance manager, you will have these serious issues. You will have challenges on that plant, I bet you. So you carry out your check. If there's no water inside your table cooler, ensure you pump water to the table cooler and make sure you monitor the gauge. Because in a control system, every of the component has a control, has a gauge. When they are getting if it has getting to the set point, it will cut off. So that's how it works. So E20 is imperative for an operator to carry it out. So before I move further, do anyone have any question to ask? E10, E20, control system, and the rest. Because we have taken more, we have spent over 30 minutes now. This we have spent 53 minutes discussing about this. If you have any question, you can.
Anyone have question, please ask. I think so. There is as Moses has told this guy Tayyab has told you. I think so. There is some communication issue, maybe understanding orally. Maybe the audience feel difficulty to understand the because PPT slides or something visual will be helpful for the audience to understand well, because language barrier is also the issue, and also something slides are visual. I mean, some parts which we can show them in PPT slides, PowerPoint slides. It will be helpful, I think so. For next lecture, if we will do in this way, it will be very helpful, I think so.
Yeah, Abib, if they have communication issue, how can we present a power plant slide with English?
Yeah. In English, PowerPoint slides will be better, I think so.
Okay, I guess some of them know English. Please, can anyone?
Yeah, English. They know English, but I think so. I think so. What I feel, I think so. There is a issue. Audience feeling this issue, and I think so. We have to prepare the slides, inshallah, next lecture, and that will be, I think so, helpful, because other webinars which I have conducted, those have PPT slides, and that was very helpful. I think so that would be helpful. It's my suggestion for you.
Okay, you can ask them. You can ask the question. You can ask them your own language. You can ask them.
Yes. Anyone have question? Just ask to Moses. Or just.
Sir, I have a question.
Okay.
Yes, please, Uzair.
Sir, as in the beginning of the webinar, we were talking about the control system, in which sir told us about the medium voltage control system and low voltage control system, and there sir told about the SAN-EVO system. So I had a question that is this system, like the AGS system and the SAN-EVO system, is it compared to the DCS system, like the distributive control system that we have in the power plants over in Pakistan? They have like a DCS system, which is connected to the emergency shutdown system, which is called ESD, and they both work together while making any numeric decision in the power plant.
If I will understand you, you are talking about the ATS system. So, if I'm not mistaken.
Uzair, can you repeat, please?
Sir, at the beginning of the webinar, we were talking about the ATS and AGS system, in which we have like AGS and SAN-EVO system as the system you told about in the medium voltage control. Uh, if you can recall, we talked about that. So my question is that what is the like basic control system in these diesel generated plants which are interconnected to other power generation, like the distributive control panel, how it is emergency performed? Like, does it have a emergency control panel or control system that is performing and with sensors?
Emergency control system is incorporated in every of the generator. Usually, the emergency comes about if the control system incorporated, the emergency incorporated in the sense that once there is a temperature raising above normal, there is an emergency alarm that will blow for a control system, a perfectly control system. It is emergency alarm. I don't know if it's emergency you are talking about. Uzair.
So my question is that okay, we have sensors who will tell us okay, there is a problem in the process and there should be alarms. But what is the process? Okay, if the sensor doesn't work, is there any emergency system for that? Like if the sensor is not working or if the sensor didn't responded or didn't give the right value for the system to see. So at that time, how we can manually or how we can have like double check the system that it is performing good or not.
Okay, that's a good question, Uzair. Like I said, that is why maintenance and control they work hand in hand. Because it's imperative you have knowledge of control, it's imperative you have knowledge of maintenance. First, in the control room, the AS panel, especially the AS panel, there's an emergency button pressed there that you press whenever there's an issues in the power plant. If for example you have 3 generators running, because the AS panel is an housing that accommodates all the auxiliaries control from the individual generators. So these when there's an issue or impromptu challenge that just pop up, for example, for example, you see fire coming out from the gen shelter, you are not allowed to enter the gen shelter. What you need to do, there's a red button in the AS panel that you just go and press. When you press the red button, all the generator will shut down. So it's incorporated like that in the generator like that. I don't know if that answered your question. You press the red button, generator will shut down, then you now go into the gen shelter. If something that's high risk emergency, you have to run out the muster point where people that are well experienced will go inside before you. You understand? Because the situation where is the gas pipeline that's leaking, for example, because in the PRMS session, there's an alarm incorporated there. So between the PRMS and the gen shelter, there's an alarm incorporated there, control alarm incorporated there, and all these things they are linked to the control room through the SCADA system. So if there's an issue in the pipeline or the flow channel, if the alarm is far from you, for example, if you cannot hear the alarm, you will see something beeping inside your office. That's a system that is well controlled and well wired when the cable is runs seamlessly. But if those alarm has issues, or there's no the alarm has issues, that is why it's imperative you incorporate this your E20 You must enter into the gen shelter every 1 hour, because this thing you just said now happened to us when I was working in one power plant. There was this oil leakage inside the power plant. The day tank, I don't know what happened. It busted. Maybe because of the heat inside the gen shelter, there was no means of ventilation. There was no chimney that takes heat out of the power plant. The thing busted. And when it busted, oil was just flowing through inside the gen shelter. Shortly after, we didn't check, we were just pressing our phones. The generator shut down. Because why? There's no alarm, there's no control incorporated inside the oil, the day tank. There's no control incorporated inside the day tank to monitor the flow. Monitor if there's an issue inside the oil, the day tank, to trigger an alarm inside the control room or inside the office. There was no control incorporated. So when it's aware, oil was just much inside the gen shelter, and shortly after we have a shutdown. We lost like 4 drums of oil, and 1 drum then was very, very expensive. So we lost 4 drums, and we are given a query then. So in a system where there's no proper control in place, to expedient, you adopt E20 for your own safety. Because where I'm working now, what I told my team is this: you must check every 30 minutes, because of my experience that I've had. Because sometimes when you leave a place, shortly after, something will just happen. You will not know. If you wait for 1 hour, it's not a serious catastrophe. So that's just what it is. So if there's no proper control in place, it's expedient to carry out E20 to check that place, ensure everything's in order to prevent unforeseen circumstances. So I don't know if that has answered your question, Zed.
Yes, sir, it does. Thank you so much for your answer.
You're welcome. So please, any other question, please, before we move further?
Sir, as we know that in the steam power plant, plant operates on Rankine cycle. Which cycle
Sir?
does power plant operates?
I didn't get that, please.
Sir, as we know that in the steam power plant operates on a Rankine cycle. So my question is that in which cycle does a gas power plant operate?
Please, can you come again, please? I cannot hear you.
Sir, as the steam power plant operates on a Rankine cycle.
Okay,
So
Rankine.
in which, yes, in gas power plant, which cycle in which gas power plant operates?
Which power plant? No, I don't understand your question.
Gas power.
You said?
In gas power plant.
Yes. It's called the CHP, Combined Heat and Power. Can you hear me? Hello? I don't know if the question you are saying, if I will understand you said steam power plant, you call it Rankine cycle. What is gas power plant called?
Yes,
Am I
in
correct?
which cycle? Yes. In gas power plant, which cycle?
CHP, right? Is CHP, Combined Heat and Power cycle power plant, combined heat and power. Are you cleared?
Can you tell us more detail about it?
Okay, about the CHP.
Yes,
The CHP,
yes, about CHP.
he said?
I said yes. Can you tell more about CHP, as you have
Okay,
said?
CHP means combined heat and power. It's all about. It's just talking about how uh, a kind of a gas is being mixed inside a gas mixer. How uh, you take it away from the intercooler. You take it through the intercooler from the mixture, from the gas mixture, which is the mixture of air and gas, because there's heat inside. So when the heat is built up inside this air, that's why we incorporate LT, the low temperature. The essence of the low temperature is to remove heat from this mixture before it goes into the combustion chambers for combustion. So that's just the name given to it by that mere analogy. How the gas comes from the PRMS and the pressure is being reduced to a high pressure through power. You understand? And the power they are talking about there is electric power, not gravity. So when the gas the pressure is being reduced to 2.5 bar, it passes through the primary pressure regulator, being reduced again. It passes into this secondary regulator. It's been reduced to 0.33 bar. Then it goes into the 0.33 bar goes into the gas mixer through the gas line. You understand? And the volume of which the 0.33 bar goes into is being controlled by the stepper motor. So that volume is being combined to the air that is coming in, combined volume with the gas and the air mixed together inside the gas mixer. Then from there, to the process of the heat, this gas being mixed together, the kind of temperature that being generated, a heat is being generated from there. So for the heat not to form anything inside the combustion chambers, there's a technology that has been incorporated called the LT to remove the heat from this mixture before it goes into the combustion chambers. So all those processes is why they call it combined heat and power cycle system for the gas power plant. Just that process is what they call it. It's just a process that's being called like that. Do I make myself clear? Do you understand it? You can make further. Can you hear me? Hello?
Yes, please.
Yes, I can hear you.
You can't hear me.
Yes, I can hear you.
Okay. Do you understand what I just said? Fasim?
A little bit because of the pronunciation issue.
Okay. After this lecture, I will try to generate a PowerPoint for this first lecture. So in the next lecture, I'm going to send you PowerPoint to the first lecture so you can get a clue of what I'm talking about. I will also add.
Yes, sir, it will be very helpful.
You said?
Yes, sir, I said PowerPoint slides will be very helpful for us to understand.
Yes, I will send you a PowerPoint of a slide of this first lecture. Then I will add it to the section 2. I will send it down to you guys for further understanding. I think I will discuss with Abib on that.
Any other question from audience? Any other question? Okay, Moses, I will just share my screen and you will just see here, for example, here you can see, here is the generator, diesel generator. Just elaborate the operation of generator. Here is the radiator and the function. Just what is the function of this one, this pipe, this pipe, and this lens, this part with this silencer. This one is the silencer, and this part. Just please one by one. Just the function of the operation, during the operation, what is the function of each part which is visible to you?
This is
Is it visible to you? Can you see these slides? I mean this video. Hello.
No
Yes,
sir,
sir, we
आपकी
can see
video
your
नहीं हो
video.
रही।
जी
We
नहीं
can
हो रही
see
शेयर?
your screen. So we can see your screen. Screen दिख रही है, video pause है अभी.
नहीं, वीडियो पॉज ही रखी है मैंने, ये सामने पार्ट सामने रखे हैं ना, ताकि वो जरा थोड़ा सा इनको बता दें अगर।
Screen shared है sir. Screen shared
अच्छा
है.
अच्छा, वो मेरे ख्याल वो शायद उनको इशू है, मेरे ख्याल सारे आउट हो गए वो। So let's wait for him, otherwise we'll end this session. Maybe we'll ask him in next session. So I think so. Let's end this session because Moses is not available anymore. So thank you for the audience to join the session, and we'll try our best because we are trying to improve the sessions. And next time, inshallah, PPT slides and also these issues which we are facing, which Tayyab highlighted or something other audience highlighted. So we'll try to improve it. In next sessions, you will see the improvement, inshallah. Hope all the best, inshallah. Thank you, Allah Hafiz.